So let's move, that is simple problem. Let's go to the next one, which is this one. So a block diagram, see a system is described with this block diagram. What is given here? The output is this. Okay, so the output of this whole system is what? It is y of t. So they are interested in evaluating the minimum sampling rate. So if you remember our sampling theorem, so sampling rate is how much here? So sampling rate is what? 1 by t, right? So sampling rate is 1 by t, should be greater than or equal to 2b. So what should be the minimum value? Which is equal to 2b, which is nothing but our Nyquist rate. Okay, so before we go into that, let us first see, let us try to plot the Fourier transforms at these locations, at A and at B. Okay, Fourier transforms. Okay, yes. So what would be the Fourier transform at A? So let us write down time domain equation at A. What will be the time domain equation at A here? X of t is multiplied with cos 1000 pi t. So at equation A, we have x of t multiplied with cos 1000 pi t. So what will be the corresponding Fourier transform? The Fourier what property is this? This is modulation property. So what happens? Fourier transform will shift to the left and right by how many units? 1000 pi units. So but Fourier transform of x of t is already given to be a triangle from minus 1000 pi to plus 1000 pi. So what will happen? The Fourier transform will shift to the left and right by 1000 units, and it will be multiplied with half, so that is okay. So if you shift this to the right by 1000 units, it will look like this, and if you shift to the left by 1000 units, it will look like this. Okay, yes. So this is the Fourier transform of the signal at A. So this is 0, this is 1000 pi, and this is 2000 pi. Okay, and this is again minus 1000 pi, and this is minus 2000 pi. Okay, so this is the Fourier transform at A. Next, the signal at A, which is x of t cos 1000 pi t, is passed through this system, whose impulse response is given by sine 1500 pi t by pi t. So what is the corresponding Fourier transform? I mean, what is the frequency response? So h of j omega would be again a rectangle, correct? So h of j omega would be a rectangle from minus 1500 pi to plus 1500 pi. Okay, so this is this is our h of t. So h of t will have this as the Fourier transform, which is our h of j omega. Okay, so minus 1500 pi to plus 1500 pi with amplitude 1. Okay, so output of the LTA system, what will happen to the frequency, or what will happen to the Fourier transform? These two fellows should get multiplied. Okay, so in time domain, what should happen here? At what would be the equation at B? B is here, right? Equation at B would be y of t, which is equal to, because it's an LTA system, this is x of t cos 1000 pi t, and this fellow should be convolved with h of t. Okay, and what will happen in frequency domain? These two Fourier transforms should get multiplied. So these two Fourier transforms should get multiplied. So how does the final Fourier transform look? I will draw it here. After multiplication, so what will happen here? So overall Fourier transform will look something like this. Okay, it looks like this. Okay, why? From minus 2000 pi to minus 1500 pi, the product would be 0, and later we will retain the function. So this should be minus 1500 pi 0, and this should be 1500 pi. Okay, so this is the shape of the Fourier transform of y of j omega. Okay, so what is the bandwidth then? So bandwidth of y of t would be equal to how much? Highest positive frequency in hertz, so that should be 750 hertz. So what is the minimum sampling rate here? So that is Nyquist rate. Okay, so minimum sampling rate, Okay, so should be equal to twice the bandwidth. So that should be equal to 2 into 750, which is nothing but 1500 samples per second. Okay, 1500 samples per second. So that is luckily the units whatever we have mentioned, they have given also the same unit. So what is the answer? 1500 samples per second. So choice B is the correct answer. Okay.